Today we're going to look at section 1.3, which is all about models and applications. So today we're going to use linear equations to solve problems. So problem solving with linear equations. Let's look at the strategy. We want to read the problem carefully. We'll let x or any variable, but usually x, represent one of the quantities in the problem. We're going to write expressions for any other unknown quantities in terms of x. We'll write an equation in x that models the verbal conditions of the problem. We'll solve the equation, answer the problem, the question to the problem, or we'll answer the problem's question. And then finally, we'll make sure that we check our solution. All right, so here's our first example. It says, got organic milk. Although our organic milk accounts for only 1.2% of the market, consumption is increasing. In 2004, Americans purchased 40.7 million gallons of organic milk, increasing at a rate of 5.6 million gallons per year. If the trend continues, when will Americans purchase 79.9 million gallons of organic milk? All right, so the question is, when will Americans purchase a particular amount? So we're talking timeline here. So let's let x equal the number of years. Okay, so it's always important to know, what do you want your variable to represent? All right, so going back to the original problem, we're talking about in 2004, Americans purchased 40.7 million, and it increased at 5.6 million gallons per year. So hopefully we're okay with noticing that if 40.7 million is like the starting amount at that particular year, and we're talking about a rate of 5.6, hopefully we're okay with the fact that we're dealing with the rate representing slope. So I want something like an equation kind of in like slope-intercept form, like y equals, we're talking about my original amount being purchased in that particular year, plus we know that it's going to increase, so it's positive at that particular rate. So this is kind of my linear equation based off of those numbers. And so if x is representing the number of years, and they're talking about, they want to know, when do we have this 79.9 million gallons purchased? Well, let's plug that value into the y, and then we'll have an equation where we can start solving for x, which will get us the number of years. So we'll have 79.9 equaling 40.7 plus 5.6x. So now we're just back to a simple two-step equation. I'm going to subtract the 40.7. That's going to give us 39.2 equaling 5.6x. We'll divide by 5.6. And so we get a value of x to be 7. So if that's how many years after the initial year that they're talking about. So if our initial year was 2004, I'm going to add 7 years on to that. And so that tells us that in 2011, that's when Americans consumed and purchased 79.9 million gallons of organic milk. Here's another example. It says you're choosing between two long-distance telephone plans. Plan A has a monthly fee of $15 with a charge of 8 cents per minute for all long-distance calls. Plan B has a monthly fee of $3 with a charge of 12 cents per minute for all long-distance calls. For how many minutes of long-distance calls will the cost of the two plans be the same? All right, so once again, we're talking about how many minutes will these two plans be equal. So we want to let x equal the number of minutes. Okay, so two different plans. So let's figure out, what does plan A look like? What does plan B look like? So going back to plan A, they're talking about $15. You have to pay that no matter what. And then 8 cents per minute for how many minutes you talk. So hopefully we're okay with an expression. My pen will let me. That we know we're paying 15, but then we've got to add on 8 cents times however long we talk. So that's what plan A represents. Plan B, you have to pay $3 per month, regardless of how many minutes you talk. But then you have to add on 12 cents for those numbers of minutes that you talk. So those are what the two plans represent. And once again, if we're talking about when will they be the same, well, to be the same means that they're going to be equal. So I'm going to set those two equal to each other. And then we'll be able to start solving for x. So I'm going to subtract the 3. And then that way I can move the x term over to the right. So then now 12 is going to equal 0.04x. And then I'll divide. And so that tells us that we're dealing with 300 for x. So once again, if the question says how many minutes will the cost of those two plans be the same, and that tells us 300 minutes would be that. Okay. Here's our next example. You inherit $5,000 with the stipulation that for the first year, the money had to be invested into two funds paying 9% and 11% annual interest. How much did you invest at each rate if the total interest earned for the year was $487? All right. So anytime we're talking about this type of investment situation where we have two different percentages, we're going to have to let x represent one of those two percentages. I always just let x represent whatever the first percentage is that's presented in the problem. So I'm going to let x equal the 9% interest. All right. So that means that for whatever amount of money I'm representing as x going in for the 9%, that means that whatever amount is left over is going to have to go into the 11%. Well, if I have $5,000 that I'm dealing with, that means that 5,000 minus x, however much that is, that's going to go in for then the 11% interest. Okay, so once again, x is representing the amount of money that we randomly are going to be putting in. So pretend like x represents $500. So if $500 is going in for the 9%, hopefully it makes sense that the amount of money that I had minus 500, that would then go in for the rest of the other percent. So that's what I mean when I'm saying x and then 5,000 minus x. All right. But whatever that value of x is, I know that putting those two things together, the investment on those two is going to add up that interest to get me this $487. I'm going to be replacing these percents. I don't like percents. I want to change them into decimals so then I can start dealing with money. So I'm going to change this so it says 0.09x because once again, if I take 9% and I divide it by 100, then that would give me that decimal that I'm looking for. So that amount of money plus then my 11% interest being multiplied by this 5,000 minus x. So once again, whatever amount of money was getting then put in for the 11%, add those two values together and it gets us the amount of interest that we earned, which was once again that $487. Okay, so now I'm going to start solving for x. So I'm going to distribute that 0.11. So then I can start combining like terms. So when I multiply, that turns into 550 minus this 0.11x. Going to combine like terms. So that's going to give me a negative 0.02x plus 500 equals 487. I'll subtract 500. So now that equals negative 63. And then I'm going to divide both sides, and negative divided by negative will give me a positive, and that's why we'll end up with 3,150. So that's representing the amount of money that I put in to the 9% interest. Okay, so that means that my answer for part of it is this $3,150 at 9%. Okay, so then that means that I now need to subtract that amount from 5,000. So 5,000 minus 3,150, that's going to give me 1,850. So that's the amount of money that I put in at the 11% interest. And there is my answer. So those two values will add up to the 5,000 that I inherited, and that's how much I put into each to get the interest that I got. All right, the next one says the length of a rectangular basketball court is 44 feet more than the width. If the perimeter of the basketball court is 288 feet, what are the dimensions? So I like to sketch a picture. I'm a visual learner. We're dealing with a rectangle here for our basketball court. If it's 44 feet more for the length than it is for the width, okay, so if the width is smaller, I'm just going to let X represent the width. So that means that I'm going to have to add 44 onto it to get the length. So my dimensions are X by X plus 44. Now, if they're talking perimeter, well, perimeter means that you want to add up all four sides. Well, in a rectangle, opposite sides are congruent. So I'm going to add X plus 44 plus X plus 44. So there's all four sides, and that equals the perimeter that we're talking about, which is 288. Start combining like terms. I've got 4 X's. 44 and 44 is 88. That equals 288. Going to subtract 88. That then gives me 4x equaling 200. I'll divide by 4, and I'll get a value of x to be 50. So it says, what are the dimensions? So remember, x was representing the width, and our units are feet. So 50 feet is going to be the width. So that means the length, which was, once again, 44 feet longer, I'm going to add 50 plus 44, which would give me 94 feet for the length. And notice how I'm clearly marking which one is the width and which one is the length, and I'm putting my units with my answer. So I would suggest you pause the video, see if you can do this other interest problem. All right, so here's what we should have had. Once again, between those two percentages, I always just let the first one be represented by what I'm plugging in for X. So the X amount is going to be 5% interest. So subtract that value from the 1,500 that I have, and that tells us how much money we're putting in for the 9% interest. I changed both those percentages into decimals, added those two values together to get what the a total amount of interest earned during that was. And then I started solving for X. That told me that only $350 went in at 5%. I subtracted that from $1,500 to get the rest to go into the 9%, which was the $1,150. All right, so that's us using linear equations to solve problems.